Okay, so now today we are going to discuss regarding the flatness measurement. So, what do you mean by flatness measurement? That's what. So, we have already discussed in the last class. We'll just have an overview of it. So, like the case of flatness measurement, it is mainly it is a minimum distance between the two planes. Hope so. You have seen the screen where it is mainly the minimum distance between two planes with which will cover all the irregularities of the surface to be tested. That's what happens in the case of flatness measurement. That is, flatness is a minimum distance between two planes which will cover all the irregularities of the surface to be tested. That's what happens. It will always cover all the irregularities of the surface which has to be tested. That what happens in the case of flatness. Then, okay, then after flatness, what happens is to be tested. See, flatness is the qualitative term which can be qualified by measuring the surface. It is the qualitative term which can be measured by measuring the surface. That's what happens. So, in one case, what you can say is flatness measurement, where it is a minimum distance between two planes with which will cover all the irregularities of the surface to be tested. And determine the flatness means to determine the best fit plane between two standard reference. That's what. Regarding the flatness, it is the means to determine the best fit plane between two standard reference planes, one above the other and one below the plane. That's what we have already discussed in the straightness. Okay, that's what we have already discussed in the straightness. That's what we say. So in the case of flatness measurement, it is a minimum distance between two planes where it will be covering all the irregularities. It will be mainly covering all the irregularities of the surface to be tested. And determining the flatness means to determine the best fit plane between the two standard reference planes, one above and one below of the plane or the surface to be tested. Now, what do you mean by flatness? Flatness is a qualitative term which can be quantified by measuring the distance. Mainly, flatness is a qualitative term which can be always quantified by measuring the distance. This is what happens in the case of flatness. Then, in one word, what you can say is flatness is a deviation of the surface from the best fitting plane than the micro surface topography. That is, it is a deviation. In one word, we can say it is a deviation of the surface from the best fitting plane. It is a deviation of the measurement from the best fitting plane. That is the macro surface topography. Then it can be defined as an absolute total value. It is always defined as the absolute total value. That's what you can say. So in the case of flatness, it is a deviation where we have a deviation of the surface from the best fitting plane. That is the macro surface topography. Then it can be divided as an absolute total value. For example, a 60 diameter disc is required to flat to 0.004 However, it is more frequently specified and deviation per unit length. That is, the disk is specified to flat minimum, and flatness can also be defined in terms of wavelength of light. So this is what happens if it's regarding the flatness. That is, flatness measurement is the minimum distance between the two planes, which will cover all the irregularities. It is a minimum distance between the two planes, which will cover all the irregularities of the surface to be tested. And determining the flatness means, mainly determining the flatness means to determine the best fit plane. It is always determining the best fit plane between two standard reference. It always determines the best fit plane between the two standard reference planes, one above and one below the plane of surface to be tested. Then flatness is a quantitative term which can be quantified by measuring the distance. It's a quantitative term which can be quantified by measuring the distance. So all this we have given an overview in the case of straightness. Okay. Now in one word, what we can say is flatness is the deviation of the surface from the best fitting plane. That is from the best fitting plane. It is a deviation of the surface from the best fitting. That is a macro surface topography. Then mainly it is defined as the absolute total value. It is always determined the absolute total value, and the flatness is tested is done by comparing the surface to be tested with accurate surface. Flatness testing is always done by the comparing. We are having a comparing the surface to be tested with an accurate surface. So always we have the surface test to be tested should be compared with an accurate or a precise test. So there is a reference point where we can measure and check what are the requirements required. That's what he say. So flatness testing is always done by comparing the surface to be tested with an accurate surface. Then flatness is analyzed by quantifying the deviations from at least squares reference plane. That's what happens. So in the case of fatness, it is always analyzed by quantifying the deviation from least to a square planes. Then geometrical floor tolerances of flatness are also considered with respect to shapes. So these are the basic deviations in the case of flatness. Okay, so now we have the various methods of flatness measurement. Okay, now we have the various methods of flatness measurement. Okay, that's what we see. Now we have the various methods of flatness measurement. So the first one was beam comparator using flatness testing. The second one was flat measurement by interferometer. Then flat measurement using laser measurement systems and flat measurement using electrochemical gauges. All these are the factors. So in this case, what happens is flat measurement methods of flat measurements beam comparators used where beam comparator is used for flatness measurement. So in this case, what happens is like the beam comparator, where we have a flatness measurement, where a flat reference plane, okay, where a where a flat reference plane is referred as surface plate. Okay, so the beam comparator used for flatness testing is a flat reference plane is referred as a surface plate. Okay, that is the methods of flatness measurement where a beam comparator is used for flatness testing. Then a flat reference plane is referred as surface plate. Okay, in the case of a methods of flatness measurement where a beam comparator is used for the flatness testing. So a flat reference plane is referred. In this case, a flat reference plane is referred as surface plate. In this case, a flat reference plate is referred as a surface plate where the beam comparator checks the general degree of flatness. Where the beam comparator checks the general degree of flatness with a method of compa- comparative measurements with a method of comparative measurements. By using beam comparator, the flatness of a surface to be tested is compared with a master plate. This is what happens in the case of a beam comparator used for flatness testing. A beam comparator is mainly used for the flatness testing, where in the case of we have a beam comparator, it is mainly used for a flatness testing where it consists of what a flat reference plate is referred to surface plate where beam comparator checks the general shape of the flatness with a method of comparative measurements, and what it consists of two outer legs which will accommodate the maximum dimensions of the surface to be tested, and first it is placed on the master plate and then on the surface under test. This is what happens with respect to the beam comparator testing used for flatness testing. So with respect to beam comparator as well, and second one was with respect to the interferometry. Then third one was using laser measurement systems, and fourth one is using electromechanical gauges. So as per our requirement or as per the functionality or as per the checking aspects, we have various methods for checking the flatness measurements according to the purpose, requirement, functionality, all that has to be considered. So in the case of this, what happens is like first one we have a beam comparator used for flatness testing, where a flat reference plate is referred as a surface plate, where a beam comparator always checks the general degree of flatness with a method of comparative measurement. By using the beam comparator, the flatness of the surface to be tested is compared with a master plate. We will be always having a master plate. So we will be having comparison with a master plate. Then what happens? It consists of two outer legs. It mainly consists of two outer legs. The maximum dimensional surface to be tested first. First, it is placed on the master plate and then on the one under the surface under this. So the readings can be taken from the indicator for comparison. If any difference exists, in this case, if any difference exists, it shows the error in the flatness in the plate under test. It always shows the error in the flatness. It mainly shows the error in the flatness of the temper test. The second one is the flatness measurement by interferometry. Okay, flatness measurement by interferometry. It's like what happens, small variations less than 1 or 2 microns, okay, less than 1 or 2 microns, less than 1 or 2 microns are measured by using this method. Okay, so what happens is like in the face of flatness measurement interferometry, it is for small, that's a high precision and accuracy means it is mainly used for small. That's what happens. So in this case, small variations, okay, small variations less than 1 or 2 microns, less than 1 or 2 microns are measured by using this method. In this case, small variations less than 1 or 2 microns are measured by using this method. It is mainly measured by using this method. So flatness measurement, it is regarding the small variations. It's always regarding the small variations that is less than 1 or 2 micron, which is measured by using this method. So the third one is flatness measurement using laser measurement systems. Okay. Now third one is flatness measurement using laser measurement systems. The third one is flatness measurements using laser measurement systems. So in this case, This measurement is used to check the accuracy of CMM tables and all types of surface plates. Okay, so in the case of all surface plates and in the case of CMM. Okay, that's what happens in the case of flatness measurement techniques. What you can anyone of you tell me what you mean by CMM? Can any one of you tell me? I have lastly discussed when we are taking the class regarding the full form of CMO. Can anyone in the class, can you tell me regarding the CMO? I'm just talking the full form of CMO. While I was discussing about the straightness, and we had a small introduction about the flatness in the last class also. We are yeah. So in that case, can anyone of you tell me the full form of CMO? Anyone? I don't like to
Coordinate
call them.
measuring machine.
Yeah, yeah. Thank you. That's what. Arab, who has told it? Who has told the answer?
Nishag.
Nishad.
Nishag. Okay, Nishag. Thank you. So CMM. Okay, coordinate measuring machine. That's what. Okay. So the explanation of CMM and what are the requirements and what are the purpose I told. All this will be discussed in the end of this module. Okay. So now here what we have is the measurement is used to check the accuracy of coordinate measuring machines, tables, and all types of surface plates. That's what happens. So in this case, in the case of measuring the straightness and flatness, and a very important factor is the surface plate. So in this case, what happens is the measurement is used to check the it's mainly the measurement. It's a measurement is used to check the accuracy of CMM tables. Okay, measurement is mainly used to check the accuracy of CMM tables and all types of surface plates. It's mainly the all types of surface plates. Okay, all types of surface plates. It determines the error and then counts them. It always determines the amount of error and then counts them. If these errors are significant, okay, if these errors are significant, then remedial work like further lapping will be done. If these errors are significant, then remedial work like further lapping will be done. This is happening. So in the case of flatness measurement, okay, in the case of flatness measurement, what happens is this measurement is used to check the accuracy of CMM. Okay, it is mainly used to check the accuracy of CMM, that is coordinate measuring machine. Okay, measuring machine. Then and all types of surface plates where it always determines the error, where it always determines the error and helps in counting them. Okay, it mainly determines the error and helps in the counting them. That's what happens here. Okay, then what happens is like error. It determines the errors and then counts them. If these errors are significant, if mainly these errors are significant, then the remedial, okay, then the remedial work like further lapping will be done. Then for making it precise, the remedial lapping, other lapping will be done. This is what happens when concerned with the flatness measurement using what laser measurement system. Then the last one is flatness measurement using electrochemical gauges, where large variations of several microns, where large variations, okay, automatically large variations, where large variations of several microns are measured by using conventional electromechanical gauges. So in this case, flatness measurement using electromechanical gauges means where we have large variations. So very high amount of large variations are available. Of large variations of several microns are measured by using conventional electromechanical gauges. Okay, so there were various gauges we have. Just that's what we have studied. Okay, I hope so. You remember the system of limits, the various gauges which we have learned in our fourth module. So, and here also, okay, we are telling about the straightness and checkers, and we are going to discuss later regarding the various types of gauges employed. But then here in the case of electromechanical gauges, large variations of several microns are measured using conventional electromechanical gauges. Okay, so especially with the non-contact type of polished surfaces, it is mainly conventional gauges, so it's a bit old, so it is not precise also when compared to the new modern technologies which we employ for the certain purpose and requirements. So in this case, flatness measurement using electromechanical gauges where sorry, large variations of several microns, where large variations. Okay, there are extremely large variations of several microns are measured by using conventional electromechanical gauges, especially with non-contact types of polished surfaces, especially with non-contact type of polished surfaces. That's what happens. Then, okay, then what happens is non-contact type of polished surfaces. Okay, then comes the surfaces. Then we are dealing with the squareness measurements. Okay, then we are mainly dealing with the squareness measurements. Okay, then we are mainly dealing with the squareness measurements, and then with the pneumatic gauging. So now we are going to discuss about the squareness measurements. Okay, what are the squareness measurements? So we are discussing about all this where we have the squareness measurements. By the time, just draw this figure where we can see the surface 1, dial gauge, standard square, and this is the surface 2. Just draw this figure by writing the heading squareness measurement. Okay. Rahul, you have drawn the figure?
Yes, sir.
Okay. So now we are going to discuss about the squareness measurement. So in starting we were studying about the checking the straightness. Then we came to the conclusion of flatness. Now it is regarding the squareness measurement. So these are the main three factors where we consider with the measurement of the instruments and techniques. So in case of squareness measurements, two related parts, okay, mainly two related parts of a machine need to meet perfectly squareness of each other. Mainly it is the mating requirement. As we know, metrology is always related to the precision and accuracy elements, everything, where it is a combination of two components which are manufactured from either aspect, and when it comes to fixation it becomes a mating and forms a single part. So the uniformity in the measurements is very highly requirement, which is always related to the fits and gauges which are employed, where we remember loose fit, tight fit, precise fit, everything we have described in the last previous module. So in this case, what happens is in the case of mating is it's always the mating of two parts or almost identical. So all the parts which is manufactured at the time in a batch will be almost having the same identical aspects, and there will be always having wear allowances, tolerances, all that aspects will be considered. Only then the process will be taken. It also amount of wear and tear will also be considered at the time of manufacturing the component for the precise, to make it precise, to make it the functioning of the product, so required aspect very precise and uniform. That's what happens. So here in the case of squareness measurements, automatically what we have two related parts. We mainly have two related parts. In the case of squareness measurements, we have two related parts of a machine which need to meet the perfect squareness of each other. In this case, we have a two related parts of a machine which need to meet the perfect squareness of each other, and which forms a measurement perspective. Okay, and which forms a measurement perspective where two straight lines or one straight line and a plane are set to a square with each other when error of parallelism is relation to be started to be standard. Okay, and the square does not exceed on limiting values. This is what happens with respect to the measurements. So in the case of measurements, what happens, we have two related parts of a machine. In this case, we have a two related parts of a machine. Okay, so you can see surface 1, surface 2, everything. Okay, we have two related parts of a machine, and need to meet the perfect squareness of each other, and it always needs to meet the perfect squareness of each other. Okay, then from a measurement perspective, okay, two straight lines or one straight line of a plane are said to be square. From as per the measurement perspective, two straight lines or one straight line of a plane are said to be square with each other when error of parallelism are relation to the standard square which does not read exceeding a limiting value. Okay, so while discussing about the square measurement, do you remember you have learned this somewhere else? Can any one of you tell me where you have find this before this? Can any one of you tell me, do you remember where you have found this before? Anirudh, can you tell me where we have discussed or where we have found this before?
Correct.
അറിയില്ല. Okay, any one of you in the class?
Sir, lab.
Where?
Lab.
Yes, Pratyush, excellent. Thank you. So we have doing the experiment, right? Can you tell me, can you name the experiment we have done last week, I think so, right? Regarding the squareness. Yes, Pratyush? Yeah.
Twofold.
Two-fold for the squareness. That's what. So it is the relation. Thank you, Pratyush. Thank you. So it is the main thing. Okay. So in the lab sections, we have already started with the measurements of metrology. So that's what happens in the manufacturing technology lab. You see, most of this, okay, most of the topics which we have discussed in the metrology has a relation in the lab, the manufacturing technology lab. You remember, I think so, the bevel protractor, the vernier caliper, then the micrometer, dial gauge, sign bar, all this we are discussing in the metrology aspect with respect to module 4 and module 5 in the case of the subject. So that's what I'm saying. Okay, so please be attentive in the lab sessions also. It's a combination. So now I hope so you remember. In that case, we have mentioned the codes. There's various respective factors. As per our requirement or as per the functionality, the squareness of the measurement can be identified or can be measured in the various aspects. It is as per the mating parts, as per the requirement, as per the functionality. All these factors has to be considered. So here what we are going to say is just an overview of the squareness measurement, and that was the practical application where in that case we are considering the whole distance and whole distance with respect to the planes. So here what I'm saying is two related parts. Okay, it is mainly the two related parts of a machine and which need to meet perfect squareness of each other. Okay, that is mainly the two related parts of a machine. Okay, it's mainly the two related parts. Okay, it's mainly the two related parts of a machine which need to meet the perfect squareness of each other. Then from a measurement perspective, okay, from a measurement perspective, two straight lines or one straight line and a plane are said to be square with each other, and when error of parallelism in the relation is to be standard and square does not exceed a limiting value, this is what happens. Then the standard square is an important the standard square is an important accessory for conducting the squareness test. It has two highly finished surfaces that are parallel to each other, okay, to a high degree of accuracy, and the dial gauge base is given on transferring the motion of the direction. So this is what happens. So every instrument which we are employed for measuring is having certain functionality, and all these functions, the main achievement of these functions is it provides better accuracy and precision when compared to the conventional methods. So automatically what happens, the time factor, the precision, the quality, and the basic, finally the output, the material which has been produced through the output will be having a high precision rate as well as high accuracy. That's what we say. The standard square is an important accessory for conducting the squareness test. Okay, so automatically we will be having a standard square, which is will become an important accessory. It will become an important accessory for conducting the squareness test, which has two highly finished surfaces, where it has two highly finished surfaces that is parallel to each other to a higher degree of accuracy, parallel to each other because with a higher degree of accuracy. Okay, then now the dial gauge base is a given for transparency motion of the direction. Mainly the dial gauge base is given on transparency motion in the direction. That's what happens with respect to the squareness measurement. This is what happens. Okay, now we have discussed about the important aspects of what instruments for checking the straightness, flatness, squareness, everything. Now we will be going to the gauging aspects. Okay, now what happens is we will be going to the gauging axis. Now we will be starting with the pneumatic gauging. What do you mean by pneumatic gauging, and what do you mean by precision gauging? That's the two other important gauging aspects where we are going to discuss. So Previously we are discussing the instruments of checking the straightness, then fitness and squareness. Now we are going to discuss regarding the pneumatic gauging and precision gauging. The name itself indicates, okay, the name itself indicates what is the functionality and requirement. Okay, so now we are going to discuss about the pneumatic gauging. So it always comes under the comparators, the mechanical comparators and the pneumatic comparators, everything. So it is also regarding the measurements only, mainly with the linear measurements, which we have already discussed. In linear measurements, where we have discussed, can you tell me regarding the linear measurements, where we have discussed in the case of linear measurements? Any one of you in the class?
Is standard measurement.
Standard measurements, linear measurements. We have discussed in the like in the just before the last online class, last offline class in the classroom, while discussing about instruments for checking the straightness. That's what there we have discussed. Okay, okay, Rahul. So now in the case of pneumatic gauging, I'll just explain what is the purpose of pneumatic gauging and precision gauging. So now we will start with pneumatic gauging. Okay, now we will be starting with pneumatic gauging. So the pneumatic gauging is what means it is a mainly use air as means of measurement. So in the case of pneumatic gauging, a device is used for measuring the linear dimensions of the machine and mechanism parts according to the flow rate of air escaping from a nozzle under pressure. That's what happens in the case of pneumatic gauging. So it will be coming under the pneumatic comparators. Okay, it will be always coming in under the pneumatic converters, and also there are various types of air escaping, like free flow. Sorry, free flow air gauge. Okay, back pressure gauge, all that exists. But here in the syllabus, we are mainly discussing about the pneumatic gauging and precision gauging, okay, and automatic gauging, all that stuff. So here first we are going to say is regarding the pneumatic gauging, where so there are various types of gauges employed according to the purpose, requirement, functionality, volume. So many factors are considered, and as per the requirement, there are various types of gauges employed for measuring. For again, it is also used for the means of measurement. Okay, in one word, we can say it is also used for the means of measurement. So now what happens is like a device. It is a device used for measuring the linear dimensions of machine. It is mainly used for measuring the linear dimensions of machines and the mechanism parts according to the flow rate of air, according to the flow rate of air escaping from a nozzle under pressure. It is mainly escaping from the nozzle under pressure. Then it is possible to gauge length, diameter, squareness, parallelism, taper, concentricity, etc. with a very simple setup. It is mainly dealing with the what diameter, squareness, parallelism, taper, concentricity, etc. using a simple setup. For instance, okay, what happens? For instance, what happens? If one is inspecting the bore of an engine cylinder, it is also possible to access its size, taper, camber, straightness in the same setting. That's what happens. So it is possible to, okay, it is always possible to gauge length, saying the gauge length. Okay, that's all. So this is achieved using several methods and is referred to a pneumatic gauging, air gauging, or pneumatic metrology. All this. So what happens is it is mainly used by air as a means of measurement, and the basic principle involved is changes in a calibrated flow respond to changes in the part feature. This is achieved using several methods and is referred as pneumatic gauging, and it's mainly referred as pneumatic gauging. And it can also be as air gauging or pneumatic metrology. Pneumatic gauge since pneumatic gauge, what happens, lends itself to a gauging of several features at once. Okay, so what happens is the pneumatic gauge lends itself to the gauging of several features at once, and it has become an indispensable part of production inspection in the industry, and also it has become an indispensable part of production. Okay, it has become an indispensable part of production inspection in the industry. It is possible to the gauge length, diameter, squareness, parallelism, taper, concentricity, etc. using a simple setup. So what happens? It is possible. It is always possible to the gauge length. Okay, it's always possible to gauge length, diameter. Okay, it's always possible to gauge length, diameter, squareness, parallelism, taper, concentricity, etc. using a single setup. That's what happens. So it is possible to gauge length, okay, gauge length, diameter, squareness, parallelism, taper, concentricity, etc. using a simple setup, okay, which is mainly using a simple setup. For instance, okay, it's mainly for instance, if one in inspecting the bore of an engine cylinder, it also provides a possible to access its size, taper, camber, and straightness in the same setting. So it is a multi-purpose aspects. Okay, it's mainly regarding the multi-purpose aspect with respect to the pneumatic gauging. So what happens is the gauge also has greater longevity because of the total absence of variable parts, and amplification may be increased without much reduction in range, unlike mechanical or electronic instruments. That's what we say. So in the case of a pneumatic comparators, and it is mainly under the pneumatic gauging, where what happens is it means mainly regarding the use of air as means of measurement. It is mainly regarding the use of air as means of a measurement. Then the basic principle involved in that changes is it is a calibrated flow respond to the changes in the part feature. It is always related to the calibrated flow of air respond to the changes in the part feature. This is achieved using several methods. This is always achieved using several methods and is referred to as pneumatic gauging or air gauging or pneumatic metrology, etc. Since it lends itself to a gauging of several features at once, it has become an indispensable part of production inspection in the industry. Since what happens, it tends, which tends, since the pneumatic gauge lends itself to a gauging of several features. Okay, several features of gauging can be done at once. So what happens? It has become an indispensable part for the production inspection of the industry. Then it is also possible to measure the gauge length, diameter, squareness, parallelism, taper, concentricity, etc. It's also possible to measure all these factors. Other than that, that's the gauge length, the diameter, the squareness, the parallelism, the taper concept, etc. Using a very simple, comparing a very simple setup when compared to its competitors. Okay, then for instance, if one is inspecting the bore of an engine cylinder, it is also possible to access its size, taper, camber, and straightness in the same setting. In a single setting, we can access so many possible aspects. That is the size, the taper, the camber, and straightness. So not only in the case of engine cylinder, also in various other aspects also it can be able to measure. Then the pneumatic gauging is quite popular because of several advantages. Okay, it is also quite popular due to the several advantages. What, like absence of metal to the metal contact, then higher amplification and low cost. That's what, absence of metal to metal contact, then higher amplification, low cost, then absence to metal contact between the gauge and the component being inspected greatly increases the accuracy of measurement. That's a very important factor, where what we describe is pneumatic gauging is quite popular because of several advantages. It is quite popular because of what? It's because of several advantages, where the absence of metal to metal contact, it's having an absence of metal to metal contact, then higher amplification and low cost. It's related to higher amplification and low cost. Then absence of metal to metal contact between the gauge and the component. Then absence of metal to metal contact between the gauge and the component being inspected greatly increases the accuracy of measurement. It always greatly increases the accuracy of measurement. It all greatly increases the accuracy of measurement. Okay, increases the accuracy of measurement. Then the gauge also has greater longevity because of the total absence of the variable parts. Always the gauge also has greater longevity due to the absence of variable parts. Then amplifications. Okay, amplifications may be increased without much reductions in range. And always in this case, amplification to an extent may be increased without much reduction in range, unlike mechanical or electronical instruments. Unlike the various other mechanical and electronical instruments. Unlike various other mechanical and electronical instruments. Okay, that's what happens. However, similar to the electronic comparators, amplification is achieved by application of power form of an external source. The amplification is always achieved by the sorry by next by the power from an external source. Hence, a pneumatic gauge does not depend on the energy imparted from the pickup. So these are the main aspects and the major functional features. Okay, and the major functional features of a pneumatic gauging are no wearing of parts, since there is no contact between the parts. Okay, since while measuring and everything there is no contact between the parts, there is no wearing of parts, so there is no surface contact, automatically it will not lose the basic properties of the material which has been tested. At the same time it will also not lose the other properties of the material it has not been tested. That's what happens. So no wearing of parts. Okay, the functional features is mainly the no wearing of parts. Second one is the rapid response. It is mainly the rapid response. Then remote positioning of gauge heads, which is mainly the remote positioning of the gauge heads. That rapid response means it is very proactive. Okay, it is very proactive where we can find it out all the requirements, all the necessary aspects. That's what it says. It's mainly very proactive. That's what in the case of functional feature there is no wearing of parts. Okay, it is mainly no wearing of parts, and then rapid response is available. Then remote positioning, it is mainly regarding the remote positioning. It's mainly on the remote positions of gauging heads. Remote positioning of gauging heads is there. Then self cleansing of heads and parts, it is also available like the self cleansing. Okay, self cleansing of heads and parts. Then no hysteresis. Then scope for inspecting the diverse part features, it is also available like the various scope, the scope for inspecting the diverse part features. Then compact size of gauge head and compact size of gauge, these are the other functional features. Okay, there are various functional features of a pneumatic gauge. What is no wearing of parts means there is no contact between the parts. Okay, in the measuring, so it will not affect the parts of the instrument as well as the parts of the object which is measured. Then rapid response, it gives a very fast response since the air. Then remote position of gauge heads, then the positioning of remote heads, then self cleaning of head and parts. It's another important factor. High pressure and no hysteresis. The scope for investing diverse part features. Then automatically the gauge of pressure is the air. So what happens is it also helps in the linear measurements, which helps in the scope. Scope for what? Scope for inspecting the diverse part features. Those helps in the measurement of the scope for measuring the diverse part features. Then it also has a compact size of the gauge, and it also plays a very compact feature of the gauge hand. And these are the other major aspects of the pneumatic comparators. Okay, and the pneumatic gauging aspects. Then also we will be having the various features like non-contact of the inspection parts is very important. The minimum gauging force is required. Then it also has a very high range of application, as we have discussed. It also has a very high range of application. Then both variable inspections and attribute inspections can be possible. Then it is also used for a variety of inspections, like you can inspect as length, position, surface topography. So all this can be done in a single setting. That's a very important aspect. All this can be done in a single setting. So what happens is it always helps in the various important factors. Okay, it always helps in the various important factors because all this can be done in a single setting. That's what happens in the case of pneumatic gauging. So then we will be discussing about the precision gauging, where all the precision and all other aspects will be taking place to an extent where it has to be done. So, like the case of precision gauging, it is also regarding the precision. It is always regarding the precision. Okay, that's what happens. That we will be having the next class regarding the precision gauging explanation, everything. Okay, I'll stop for the time being. Students, please don't go. By the meantime, we will